Hello everyone and welcome to this introductory video about basic SSLi topologies. In this video we are going to look at some of the basic SSLi topologies. This includes the L2 topology with a single path, L2 topology with multiple paths, L3 topology with single path, and L3 topology with multiple paths. Moving on to the first topology, we look at L2 topology with a single path. In this topology, we have a client machine on one side of the network and a gateway router on the other side. There is an A10 device and a security device connected to the A10 device in the middle. All these devices are in the same subnet, which is 10.1.1.0 in our example. The gateway router is directly accessible from the client machine. Since this is a layer 2 topology, there is no IP change required on the network, and the security device will be in a bump in the wire mode. For this topology to work, we'll need a total of 4 physical interfaces on the A10 device. The first interface is used to receive SSL traffic from the client machine. The second interface is used to send out HTTP traffic towards the security device. The third interface receives the HTTP traffic back from the security device on the A10 SSLi device. And the fourth and the final interface is used to send out re-encrypted SSL traffic towards the gateway router. These first two interfaces will be grouped together and given a single IP address, which is 10.1.1.2. Similarly, the last two interfaces are also grouped together and given a single IP address, which is 10.1.1.3. You should keep in mind that all of these IP addresses should be in the same subnet, that is 10.1.1.0. Now moving on to the multiple paths L2 topology, we have the exact same network. The only difference in this topology is that we are going to add a second security device to the network. For this, we'll need a set of 2 more interfaces on the A10 device. The security device will be connected to these interfaces in the same fashion that the first security device was connected to the A10 device, and we will give these interfaces their own IP addresses. One thing to keep in mind is that the second security device will be in a separate subnet. In order to differentiate between the two separate subnets, we've used color coding. So you can see that the green subnet was the original subnet that we previously had, and now we've added a new subnet to the network, which is the red one, namely the 11.1.1.0. Keep in mind that traffic traversing through the security device B will not experience any IP change. Now that we have 2 security devices connected to the network, we can load balance between the two. Moving on, we'll look at the L3 topology with a single path. Here, like L2 topology, we have a client machine connected to an A10 device. On one interface, we need another interface to connect to the security device for outgoing traffic, third interface for incoming traffic from the security device, and a fourth and final interface for connecting to the gateway router. In this topology, the A10 device becomes an L3 hop between the client and the gateway router. The default gateway on the client has to be changed, and it will be given the IP address of this interface so that traffic can be sent towards the A10 device. The security device can either be in bump in the wire mode or routed mode. Traffic flows the same way as L2 topology. SSL traffic from the client enters the A10 device. It is decrypted, sent out to the security device. The security device sends the traffic back towards the A10 device, where it is re-encrypted and sent out to the gateway router. Here, we won't do any grouping of the interfaces. In fact, we'll have a separate IP address configured on each and every interface. We have a total of 3 different subnets in this topology. You can differentiate between them by looking at the different color codes. For example, the first interface for incoming traffic is in the subnet 10.1.1.0, which is the same subnet as the client machine. The second and third interfaces have their own IP addresses but are in a subnet of their own, which is 12.1.1.0. And the fourth and the final interface is in another subnet, which is 15.1.1.0, which is the same subnet as the gateway router. You can see from the diagram that in this topology, change of IP address will take place. Now let's look at L3 topology with multiple paths. The topology looks similar to L3 topology with single path, but the difference comes in when we take two more interfaces on the A10 device and connect a new security device, namely security device B, to the network. Security device B is connected the same way that security device A is connected to the A10 device. The only difference is that security device B will be on a separate subnet. You can see that the subnet that we've chosen in this example is 13.1.1.0. We'll assign separate IP addresses to both the interfaces, one for the outgoing and one for incoming traffic. These two devices will load balance the traffic among themselves. So in total, in this example, we have 4 different subnets. All have been color-coded for easy understanding. One important thing to note here is that in all of these topologies, the original source and destination IP address of a packet traversing from the client to the server machine and vice versa will not be changed. That's it for this video. Please join us next time where we'll go into the details of these topologies and more. Thank you.